It's another walk video. So I don't know if you can tell from the title of this video, but today we're going to be doing some scrap mechanics science to answer a question about walks. Now the question is, you can see that these walks walk around. They have a certain speed to them, so they walk a certain distance for a certain time. We can go ahead and call this a walk-walk. It's a walk-walking, so it's just a walk. It's a walk-walk, right? So the question that I have is, how many walk-walks would a walk have to walk around the block? And I'm not talking about the traditional sense of a person walking around the block. I'm talking about an actual block, a single block in the game scrap mechanic. And you think that answer might be 4. Please, I'm trying to do a video here. What are you doing? What are you doing? Just, ugh, get out of here. Get out of here. I'm trying to show the block. Look, it's not corn. It's just a block. Get out of here. I'll get you when the time comes to do the experiment, but not now. I'm trying to explain what it is. Thank you. No. No. Okay. Anyway, you'd think that the answer would just be 4, since each side of the block is just 1 block long. So this side is 1 block, this side's 1 block, this side's 1 block, and this side's 1 block. So you think that the distance to walk around the block is just 4, but that's not actually the case because a walk is thicker than 1 block. So the first thing that we gotta do is actually measure how thick a walk is. And then from there we can do some calculations to get an estimate of what the actual distance that a walk has to cover to actually walk around the block is. So let's go ahead and get started by building a measuring device. A contraption here that's gonna help us measure how thick a walk is. How do I actually do that? You know, I'm a little bit curious actually. How thick is this capsule part? It's 11 blocks thick. So then we're working with an odd width here. These walk are gonna get annoying, let me tell you. In the background of my video, it's gonna get so annoying. So we're gonna use this center point as sort of the basis for our measuring device. Next, we need some bearings. We're gonna try, let's do 1, 2, 3. We're gonna do just 2. I don't know how thick a walk actually is, so we're gonna have to work a little bit here. If I build a wall here like this, and a wall here like this, and we do the same thing on this side, build a little wall. Then we're gonna put this on a controller right here and right here. 5 should be pretty good, I think. All right, so over here you can see I have a funnel, and I think the dwarf is still thin enough to walk through it, but I'm not sure if a walk actually is. So I guess let's go ahead and test that, and then we'll see the stopping point for the walk, and then we can get a good measurement for how thick it is exactly. So to really test this, I need some corn. Where's the corn? Corn? Give me, where's the corn? Give me some corn. Corn. Yeah. All you guys want some corn. Here's some corn. Everybody get some corn. Okay? Stop your complaining. Everybody gets corn. Mer, I want some more corn, mer. Anyway, we're just gonna put some corn here in a line to sort of entice this walk to walk in a straight line. Hey, I said walk again. Anyway, unleash this walk and see how far it goes. No veering off to the side now. Did we already get it? We already got it. No way. No way that you're that thick. I'm pretty sure you can fit. No. The other walk's gonna get the corn. You sure if I don't put it like right in front, you're not gonna get it? It's just not going. It's just not going anymore. Wow. Why aren't you going for the corn? What do you know? I guess that's the limit for the walk. Okay, so now what we're gonna do is we're gonna take a measurement of how far this walk actually made it into this wedge piece here. Because I'm not sure exactly where that is. I can't exactly see the walk collision, so I'm not exactly sure where it's held up. If it's colliding right here, then we can just measure the distance across here and get the thickness of the walk. So let's go ahead and be a little bit more precise about this by putting a sensor right here so we can get the distance to see exactly where the walk stopped. And that's gonna be giving us the distance to the walk. So now we can just get a number readout. 15 blocks? Really? 15 exactly or what? So 15.43. Let's see if we can push it any closer. 15. Okay, so it went down to like 15.2, but now it seems like the No, get out of here. Get out of here. Get out of here. That's corn is not for you. Just get out of here. Get out of here. Get out of here. You got your corn. Oh my gosh, you sneak in a corn and get... Don't ruin the experiment. Just get out of here. Come on, here's some corn. Get your corn and get out. Why isn't it going for the corn? Every other walk's going for the corn, why not you? Come on, just get all the corn and get out. All the way away from the experiment, just get out. There you go, fellas. There you go. Okay, so 15.37 seems to be the distance to go. So a smart engine controlling this piston, and we're gonna put in the sensor directly for the length value. There you go. And just like that, the smart engine will extend precisely 15.37 units. So this is where the walk is actually getting stopped by the wall. All right, so then let's see what this is. There's 1 block, 2 block. Oh, I can't even put that there. 3 block, 4, 5, 6, 7. And it cuts into each of the blocks halfway. So is the walk only 6 blocks thick? So because of the way that I built this, you gotta understand that the piston takes up 1 block in itself. So that's why it's back 1 block from the sensor. The sensor starts sensing right at the sensor lens, and that's why we get a precise reading of 15.37. So we're gonna be starting our measurement from the tip of the piston. And that tip of the piston goes 15.37. So where the piston actually meets the block, that's where the collision point is. So that's actually kind of convenient because if you look, it seems like it's right in the center of this block over here. So we might actually be able to use that for our measurement. If we put a bearing right here across the way, and then we build up a couple of blocks, and we go ahead and put a sensor facing this way. What? No. Stop sneaking the corn. No. No, my experiment. Get out of here. Get out of here, Wocs. No corn for you. Anyway, we can just take this bearing, put it into the controller, and also turn it by 5 degrees. So now it's going directly across. That's exactly what we want. So then on this side, we can actually build like this, part of the same wall. Okay, so now that we turned this bearing, the sensor is aligned perfectly straight. So it's going to be shooting out a sensing ray, again from the sensor lens, directly across to hit this wooden section right here, which is part of this whole slanted wall. So what we're doing is we're getting the measured distance from this point to this point across the wall here, and this is going to be our walk width, how thick the walk is. And the walk's thickness is 5.788. 5.788 blocks thick. This is assuming that the walk stop trying to sneak the corn. What are you doing? Sneaking corn? You're not supposed to be doing that. Get out of here. And that's all under the assumption that the walk stopped exactly 15.4 blocks. As a matter of fact, something else that we could do. You know, let's try to do this a better way. An even better way than this. Okay, instead of this block here, we're gonna put a sensor there. But because the sensor actually starts sensing directly in the center of the sensor instead of where the piston meets the sensor, we need to subtract 0.5 from the piston length to position the sensor exactly where the walk is, and then feed that into the piston length, and that's gonna stop precisely where the walk is colliding with the wall. Yeah, I actually don't know if the walk is too tall, now that I'm thinking about it. I need to put another sensor on top. Okay, putting another sensor on top because I didn't realize I might be sensing the walk's head, but now I just should be able to put an extra wall up here to collide with this sensor. So with that extra wall on top, the top sensor is gonna sense the distance to that wall. So it's going to be the walk's width plus whatever this distance here is from the edge of the sensor to the edge of this wall. I'm not exactly sure how much that is. There must be a way to measure that too. Let's go ahead and do another sensor reading to see what we can get. Put another piston on there. This time let's use a regular sensor. There you go, color mode is what I wanted. So we can go ahead and just paint this section white. So this sensor is going to be sensing stuff. Let's go ahead and put this piston on a smart controller. Speed setting can just be, you get out of here, Wocs. There's no corn for you. Get out. I have my hammer. Don't make me use it. Hook up the distance measurement. And this is going to go into this piston up here. So basically we're going to be counting up by 0.01 into the distance measurement for the top piston up there. And that's going to be powered by this sensor up here. So the very millisecond that the sensor stops sensing the white paint color up here, it's going to stop with a precise measurement of how far this slanted wall is taking up on the internal space here. Yeah, let's go ahead and hook this up right here. Boop. And we can see the sensor moved out very, very precisely so that it's just out of the way of the internal wall here. All right, so 0.19 is how much this piston had to extend. Oh, but it's actually plus half a block because this sensor starts sensing in the center of its position. So it's already half a block plus 0.19. So haha, it's it's 0.69. Hey. So anyway, 0.69 is the distance of this internal wall here that we have to subtract from this distance sensor reading right up here. So let's go ahead and get to that. So this sensor is saying 6 point something. Woc, what are you doing here? What are you doing here? Get out of here. I'm just gonna be smacking you because you're not following the rules. There's plenty of corn there for you, just go get it. Alright, so you gotta remember this top sensor is getting 6.41 for the Woc's width, but we have to subtract 0.69. There you go. So that distance minus 0.69 gives us our actual Woc width. Should be right here. Our actual Woc width is 5.72. Well, would you look at that? 5.72. Let's see if that actually is accurate. We can try resetting this just to have it count up to the same amount, 5.72. So far, I think we've got a pretty accurate reading. 15.38. Let's see if we can push this Woc any farther. Sorry, Woc, this is for the sake of experimentation. Okay, it's definitely not gonna... Yeah, whoops. Ah, see, now it's trying to measure where I am. So we open the crate, open the capsule, it's starting to eat its way in there. It's done all the corn. Okay, so now if I just, boom, knock it. Okay, that's not exactly right. It's not exactly right. Let's get it out of here. All right. Just no. What are you doing? What are you doing? Just run in there. Just run in there. All you gotta do is just run in there. Not. What are you doing? What are you doing, Woc? That's dead. I didn't even realize you were that strong. What are you doing? Oh, yeah. All you gotta do is just run in there. That's all you gotta do is just run as far as you can. You don't have to push anything. Let's just go with the corn. Let's just go, the corn. The corn's the only thing I can really depend on here. 15.2. And it's trying to get the next corn. That's good. 15.2, 15.22, 15.3. We reset this. Oh, it went to 0.2 this time. Let's fix our measurements a little bit here. The 0.5 that we have to add for the sensor. In a plus block, add this to this. There you go. There you go. So the sensor reading minus this guy, 5.701. Was that the same number that we got last time? I already forgot. 5.7 seems to be the Woc's width right now. What is this other Woc doing? What is, like, get out of here. Get out of here. Murr. All right, so 5.7 whatever. I think we're just gonna be a little bit negligible here and just say 5.7. We just round it to 5.7. That's our final thickness measurement is 5.7. All right, so now let's go ahead and try to build a little thing. How far can I entice a Woc with corn? Oh, that was pretty far. Hey, that's pretty far. That's pretty good, actually. That's pretty good. So we're gonna use that. I don't know if this is gonna work actually now that I'm doing it. But if I put a corn up here, there you go. It's enticed to get the corn. That's exactly what I wanted. We just have to spin this. That didn't really work like I thought it would. Come on, Woc. You're not trying to get the corn or what? Could put another one on. Could put another one on. How are you not going for the corn? Okay, so this is basically what I wanted to try to entice this Woc to walk in a circular path. It's a little bit too wide of a circle, but hey, this is actually pretty good, so let's try to speed it up. Maybe we can get the Woc to try to take a shortcut. Woc, wow, its sense of direction doesn't actually update for a while. Wow, what are you doing? It's like it doesn't even know what to do, how to walk around this. Uh-oh. Maybe a Woc can't actually walk around the block. What? I'm so confused by Woc behavior. Get out of here. I'm looking for Woc that chase corn. Man, that's weird. Why? I thought, like, I thought it would be pretty easy to get a Woc to just hug around a single block pole. But it's just not doing that. Well, luckily we can still answer this question with math. Let's go ahead and do a little bit of graphic drawing here to answer the question what a 5.7 block thick Woc can actually do to walk around the block. Let's do that. Alright, so Adventures of MS Paint, let's do this. So we know that a block is exactly 1 block thick. Big revelation there, I know, right? But the thing that we didn't know is that a Woc is 5.7 blocks thick. So 5.7, let's go ahead and like slice it off right here just as an approximation. So this is the distance, this is the width of 1 Woc right here. So this right here is approximately the width of 1 block. And we'll just go ahead and move that over to the corner over there. So the thing that we actually have to calculate is the path that the Woc would actually take, the pathway that the Woc would actually walk in. So if we go 5.7 divided by 2, that is equal to 2.85. This is the radius of the Woc, so to speak. So you gotta remember from the edge of this block, because the Woc's not gonna walk inside the block, from the edge of the block, we need to go 2.85 blocks. So out here is actually the center point of the Woc, and if you take a look at a Woc's collision, it's gonna be like pretty darn thick like this. You gotta remember it's as thick as this line over here, so when we center it up, you're gonna see that it lines up exactly with the center of the Woc, and this is the problem that we actually come to when we have to answer the question, how big is this distance? And this distance, this minimum distance that a Woc can theoretically be close to a block, it applies to every single side of the block. So a Woc's position can only be 2.85 blocks close to the block that it's next to on any side, whether it's the top side, bottom side, left side, right side. So we know how far a Woc can be from a block. So if a Woc's path actually starts from the right side over here, we know that a Woc travels at the least 1 block distance to cover this entire side. But then it's going to take a circular path to reach this point over here. And that's because that radius has to go around this corner here. So this is also going to be 2.85 right here. And this is the distance that we're measuring because this is going to be 1 up here. This is going to be 1 down here. There's going to be 1 down here. And there's going to be 1 over here somewhere. So we already know that the distance is at least 4, but then we also got to calculate the quarter circle distance right here of a circle radius 2.85. Luckily, there's actually 4 of them going all the way around, so really all that we need is just the circumference of a circle with radius 2.85. And we know to get the circumference of a circle, you just do 2 pi times the radius. So let's pull out the handy-dandy Windows calculator. Scientific. Yeah, give me pi exactly. So we already know that the radius of the circle is 2.85. Now we just need to multiply that by 2, and then multiply that again. Wow, who would have guessed we already knew 5.7? Then we just need to multiply that by pi to get the answer 17.90707. 81, yada yada yada. We don't need that many digit places. So this value of 17.907, this accounts for the distance that the circle covers just by itself, and it doesn't account for the 4 sides of the block. It's just the distance that the Woc has to cover to go around the corner. So we actually take 17.9 and add 4 to it to account for all 4 sides of the block, and then we finally get our answer, 21.907, or if we were to round it up, just 22 blocks. That is the distance that a Woc has to cover to walk around the block. So at the very least, we were able to answer the question, how many blocks does a Woc have to walk around the block? And we know that that answer is approximately 22 blocks. Alright, well, it looks like I wasn't able to get a Woc to walk properly to walk around the block. So the answer to the question, how many Woc-Walks does it take for a Woc to walk around the block? I don't know. I actually don't know because an actual Woc doesn't walk around the block. It just refuses to do so. But theoretically, we can answer the question, how much does it take for a walk to walk around the block? The answer is approximately 22 blocks. So hopefully you guys like this episode of Scrap Mechanics Science. Be sure to hit the like button if you like it and you want to see more like it. Let me know down in the comments below. Maybe I could have done something different. You know, my scientific process isn't exactly perfect, but hey, we're dealing with Wocs here. I don't know exactly, like, it's just, if you were to see inside of a Woc brain, it's just, kern, lots of kern. There's only so much that we can do, but hey, you guys let me know down in the comments below what you think. Thanks for watching, and I'll see you guys next time. Kern! Look at this guy. Look at this dude. Still trying to get the unreachable corn. Speed setting could just be... You get out of here. Get out of here, Wocs. There's no corn for you. Get out. Get out. I have my hammer. Don't make me use it. Don't make me use it. Go on. Get. I'm gonna smack you. Just walk the other way. Do your walk the other way. What, you don't understand? Maybe you understand. Muh! 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 No. Look, I'll give you guys some corn over here, okay? How is this walk not...